Hello everyone, so in this video let us talk about the E problem from the latest Codeforces round 827 problem named Scuza. So Timur has a staircase with n steps, as you can see the diagram as well. Now the ith step is AI meter higher than its predecessor. What it actually means, let's say the starting one is 0, then the A of I, let's say A of 1, it is given as let's say 1. So the first step is 1. Then the next one is let's say A of I is 2, which means that it is 2 meter more in length than its predecessor stair. So the let's say the predecessor of this is 1. The next one is 2 more high. So the length of that is 3. So then the next one is 3 meter more high. So let's say its length is like 2 plus 3, which is 5. So whatever A of I is given to you is this is you just take the previous height, whatever sums that you have taken, and just add it that to get the next staircase length. Okay. Now it starts from 0 that is given to you. Now the problem statement goes from here that Timur has q questions. Now each denotes an integer k. So you have k questions, you have to add the answer. But now what you're actually given is that for each question k of I, you have to print out the maximum possible height Timur can achieve, okay, by climbing the steps if his legs are of length k of I. So k of I is the length of Timur, that person, and what is the maximum height Timur can reach uh, if he has the legs of height k of I. That's a problem. Now there's some more thing that you have to understand, that Timur can only climb the jth step. Okay, go to the next step if his legs are of the length at least a of j. So you can only go to the next step if your length is at least a of j. Okay, so, or else you cannot go to the, and that's it. You just have to find out how much highest point. Now it's pretty much simple, not too much difficult. Whenever I see I like this type problem, what I can see is, let's say, to try to find out some examples from here as well, and then you can directly just intuitively get what is the problem statement. So what you can see is that eventually, like, the first step is, and the next step is more than it, the next step is more than. So it is like an increasing, like, let's say increasing staircase value. Whenever I see increasing some sort of thing, it is somewhat start to hit that it is some sort of binary search problem, because when I see monotonic problems, so like increasing or decreasing, and I want to search over it, I want to get a particular point out of it, like maximum height I can get to, like lowest I can get to. So binary search start to hit at me. Okay, then why binary search? Like, why can I do? Like, can we start using something? So let's take the example of the first one, like 1 2 1. So 1 2 1 5 is A of I. Okay, now what you can say is that first you have to like draw out this case. So let's say the first one starts from 0. Then I have a height of, let's say, 1. Okay, this one is 1, and I've got two height of 1. Then the next height is 2. This height is, let's say, 2. So the total height I've got is 3. Now the next height is, let's say, 1 again, and then the next height is, let's say, 5. So that's the overall maximum height I have reached. So to get the maximum height, like the height of every point, you can directly just add the previous value. So let's say this is 0, then this height is 1. Okay, this height is, let's say, 3, and this is 4 plus that is. So you have got the height of every staircase. So if I want to like know what is the maximum height I want to reach to, I have to somewhat get the staircase at the height, because that's the maximum height I can get to. Okay, that is the thing that I want to get. Now I just want to know that what is the maximum point I can get to. Thing is that I can go to the next staircase if my legs is at least that much height. So let's say my legs is, let's say, 3. Can I jump over this? 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 So, okay, I should stop at this point. Like, how can I know that where should I stop? So the very simple thing is that I should just find out the maximum till this point, because if I can jump to the maximum, and all the minimum also I can jump. So the thing is, I just have to store the maximum till any point. Okay, and also that will be also monotonous, like monotonic function, because it either it will increase or it will stay constant. Like either the maximum will increase, like maximum stay, or like it will remain constant, like all of them are. What I want to understand from here is that if I can jump, let's say I have a total of, let's say, 2 height, so I can jump at this, like I can jump on to this also, this also. I have a maximum height of this, I can jump over this, I cannot jump over. What I mean by this is that I have to first understand like what is the maximum I can jump to. Okay, so I just have to store one, like the maximum at any point. So I have to store two values, the sum of these staircases value and the maximum. And then I want to know that what is the maximum I can go to, so I can just do a, let's say, upper bound. Okay, I can just do a binary search to get the very maximum value I can go to, and then whatever staircase I can get to, I just directly go to the sum array that I've built. That okay, I can reach to this staircase. So what is the sum of the values of staircase at this particular point? So let's say this is 4. So I can go to this staircase that is of total length of, let's say, 4, and that's the 4 maximum height. That's the overall logic that we have to use in the problem as well. Nothing much complicated. So what we'll do, I'll just show you in the code part. What we have done is that we have first made a prefix array that is the sum of all the numbers still at any point, ith point, and then the maximum at the ith point. Then we have taken all the queries one by one. Then we have to find out the maximum I can go to. Okay, so I just use an upper bound function to find the value, like what is the maximum. So this is just doing binary search. I have different videos on upper bound. You can draw, or you can just upper bound on the internet, and you can that. So it's just doing a binary search to get the maximum value on a monotonic function, to get like what is the maximum value I can get to, and you can just get index, because if I subtracting out mi dot begin, this will give you the index. If I just put a star at the end, I will get the value. And so that is how I can dereference it. And if I subtract out the starting iterator value, then I will get the index. So I will get the index, like what is the maximum index I can get. And I will just check out the index should be inbound. Okay, if it's out of bound, then I cannot use it. If it is out, obviously I will just take that and just find out what is the height at that particular. Height is stored inside the height of the staircases that in the prefix that I'm out, that particular index, and find the point and just print. That's our logic that we will be called the fifth. Well, if you still have any doubts, you can mention in the comment box of this problem. I will see you in an experimental